So, we're going to be talking about NodeBots, but a little bit more than that. We're actually going to get around to building one, or a few. But before we get into that, what is a NodeBot? So a NodeBot is really just any hardware that you're going to control from Node.js. And tonight we're going to be using the Johnny 5 node module to do that. There's a couple other ones. We'll talk about that later. But so Johnny 5 is, I want to say it was originally made by Rick Waldron. It's maintained by several people, mainly him. He's pretty active on Twitter and stuff like that. He'll respond. They take pull requests. But you just npm install Johnny 5 and you get it. So currently they have support for Arduino. Uno is just any Arduino firmware really. You'll load a standard Fermata. We'll do that in a second. They also have support for Raspberry Pi, BeagleBone, the Intel Galileo board, Spark cores, Pinocchio boards, and they'll also take a generic I/O board. So if you do your own PCB, you can configure it to work with Johnny 5. So the setup for Johnny 5 is pretty simple. You have to have Node and npm installed, and you want to load the standard Fermata sketch onto your Arduino if you're doing an Arduino. I haven't messed with the Raspberry Pi stuff yet. I've got one on order. Then wherever you're making your Node.js app, you'll npm install Johnny 5 and require it, and then find a new board, and we're about to do all this. So let's see. That's not gonna reach. I forgot a longer USB cable, so we will make do with this. All right, let me do that. Yeah, there we go. That, yeah. All right. So that up. Okay. So this is the Arduino IDE. So to load the standard Fermata, what you need for Johnny 5 to be able to talk to the Arduino, first thing you want to do is check your board, make sure you have the right one. We're doing an Arduino Uno. It's the default setting, but they have minis. I've messed with it with nanos, works fine. So then under examples, there is Fermata, and you want the standard Fermata. So load that up, you can compile it to verify it, and push it to the board. So now our Arduino is ready. And where I lost all my settings. There it is. Other. Hey, there we go. Yeah, there we go. All right. This is. Where's my notes? That didn't work. Yeah. Command plus. Good. There we go. All right. Where are we at? I was planning on having all this set up before, and then my computer died. Okay. Yeah. All right. So do is npm install 95, and that will go out and grab the standard for Mata, and all that fun stuff from Google or from NPM. All right, so for require 5 there. So the require just gets access to the module. We want to define a new board. Board. If you don't give it any parameters, it'll search for the serial port over USB. You can actually send it options and tell it what USB port to open and all that, but by default, it'll just find it for you and be good there. Board on. So this will get fired off once it's connected to the board and the board is ready. And I've got an LED hooked up to pin number 3. Oh, thank you. Yay. Yeah, I can't fucking hold it.
I can stand here and hold it.
To be my assistant? Oh, there we go. Alright, so it's on pin number 3. And then LED dot pulse. And that's just going to pulse the LED on and off. You can do on, you can do off, you can set a brightness as long as it's a PWM pin. So let's see that. And go here. Node LED.js. See if I didn't break anything. Hey. And there's that. This all worked way better in my head. But yeah. So then it's pulsing. So, really simple demo for that. All right. So that's the easy one. Go back with my cursor. Back up here. All right. So this guy is a Sumobot Junior. It's an open source design. It's a laser cut frame, 2 servos, battery pack, and Arduino Uno. Pretty simple bot, completely free. I don't want to butcher his name, but that guy designed it for NodeBots Day last year. The GitHub, the cutting plans are available. You can have the laser cut parts plan. They got a code example. He actually did a 3D printed version. If you have a 3D printer but don't have a laser cutter, you can fully 3D print it. This one. That one, no. So it consists of one Arduino Uno, a laser cut frame with 2 wheels, a laser cut, rubber bands for traction. This is the optional 3D printed hubs. They're just a little easier to install rather than screwing into the servo mount. Google. 2 servos, and you wire the servos into a battery pack, which is fun. All right. So let's see. Oh yeah, they all look like that. That's this one. And there we go.
Are you losing a soccer?
This was not fantastic. All right. Yeah. All right. So now we build a robot. That's hot. All right. So first thing we got to do is, oh, where am I at? Way over here. Didn't work. There we go. All right. So first thing we got to do is cut the leads off of the servos so that we can wire them up straight. So once they're stripped, can separate them out. Whee. So we have red wire for 5 volts, black for ground, and white is the signal wire. So, do the other one. Let's feel this. All right. So now for the part. Couple screws to mount the servos in. And another screwdriver. So feed the wires to the hole. Servo fits in like so. To make sure the wire's on the back because the adjustment screw is on the back. We will not be using the spline, so I'm going to take that off. Ah. The original design for this is a little bit bigger, and it uses zip ties to hold the servos in. It uses this body, so you have zip tie holes and no mounting holes on the side. This is an updated design. It's a little bit smaller and compact, so I went with the latest just to try it out. So one in. Okay, cool. Feed these wires through. Again, remove this spline. And the guy who originally did this actually has a YouTube video up of building one of these. So this will actually be on YouTube too. But if you want to see the nice edited version with cuts and all that, you can go to YouTube. All right, so easy part's done. Servos in. Now comes a slightly more challenging and fun part. That is soldering. And my soldering skills are amateur at best and pretty dodgy at worst, but I'll get through. A friendly set of helping hands. And everyone who solders best friend, flux. So that on there. Pull some solder off. Oh. Okay. Go. All right. How's that? Let's go this way. That's better. All right. All right. So we're going to be soldering the power lines from the servos directly to the battery pack. Oh, that was nice. So we just want to kind of tin these up a little bit so they'll solder easier to the battery pack, which is the fun part, which is over here. So let's see, hold that off. That might be a little too hot. All right. So the solder will hold the wires together, and I'll solder them to the battery pack to get a good circuit and direct power off the 4 AA's instead of from the Arduino. Again, handy flux. Easy peasy. It's supposed to be. Apparently you do not want to breathe that in. From what I'm told. All right, now comes the fun part. Drop a solder. All right, so those are the two ends that we're going to solder the servo power directly to. Which is fun because it's plastic and trying. So usually what I do, last couple times, is get through there, and then clamp it down with needle nose, hold it in place. And let's see. Something. Usually have a spare piece of wire for this. Let's do this. All right. Again, apply flux liberally. Let's see. Okay, good. I'm burning the shit. And this is the part that I was worried most about. There we go. Not too bad. Oh yeah, never mind. When I first built this, I did this twice. I couldn't quite get it right, and I practiced last night and got it right first time. And now that I'm in front of everybody, that's not happening. All right, so that's the negative. And I'm off. And it came off. That's great. That's what happens when you live solder. And I chewed this, didn't I? Yay. Let's see. All else fails, I have another one of these. It's not nearly as exciting. I don't fail miserably. So again, as I said, soldering skills are not so great. And that's not going to work. Alrighty. Nope. Alright. Time out. Try this again.
What are the two wires on there?
So these are power, same thing off. I'm going to snip this one off, and this one's actually going to go to the Arduino to complete the circuit. Could cheat and do that. You don't have to. How the demo was, and I was gonna, yeah. Let me cheat. Let me do this. Okay. I thought about doing this, but it'll take longer. But it'll be easier, and it'll work, hopefully. Electrical tape. So, let's see. Okay. Let's go back to the helping hands. Restart from scratch. This. All right. So, what we'll do instead is we'll tap into these wires and put a lead off the negative. We'll need what? We'll have a little bit extra, a lot of extra slack, but I can always cut that off later and redo all this when I don't have a bunch of people staring at me, watching me do this. So again, apply flux liberally. Get these tinned up and together. Strip this out to give a little bit of extra meat to solder to. Apply flux liberally. Actually, let me, the message up one. Right. That's the other one. Oh, there's a chewed up one. I cut off the wrong one. Okay, so if we can put this together. Huh? That should do it. Let me, again. So I thought about doing this, but knew it would be a lot longer, and decided against it. And then the other one didn't work. So here we are anyway. Make sure we get a good connection there. Should be good there. And then what we'll do is we'll come off of this one. And then this will go back to the Arduino and complete the circuit. I will not burn the table. Spin that around a little bit. Apply some flux. And this is about the worst soldering job I've ever done. But that's what happens when you do fun stuff like this.
You do it live in front of 40 people.
Yeah, and the internet. All right, so that's done. I have heat shrink at the house. I didn't bring it. So good old electrical tape and a knife. Alright, so tape that up. Time. Oh, 7.5 hours. Oh, yeah, I'm doing good. Alright, so that much tape. Yeah, cut away from myself. So we now have both of the negative leads off the servos wired up with the lead off to go back to the Arduino. So we'll take the power connectors, put those in here, apply flux liberally, get some extra meat off the power line. Let's see if I can. Okay. And be done with all the soldering. See what I did? All right. All right. That's done. Thank God. So we'll tape that up. Now we're good and powered. So we have a battery pack. Add 4 batteries.
You said earlier the red line of the servo takes 5 volts.
Or is it 5? I think so, yeah. These are 5, right?
So 4 AA batteries.
1.27 volts each. Yeah. So battery pack slides in nice and snug here. Maybe. Very snug. There. Alrighty, let's do an easy part. So underneath, we need a front wheel. So what you got is a little 3D printed ball caster.
Where'd you get these parts from?
So the 3D printed parts I bought off of Shapeways. If you have a 3D printer or makerspace you can go to, it probably cost about 20 cents in plastic to print this off. This takes a 16 millimeter steel bearing ball, which apparently is impossible to find. But luckily, if you have kids, you have marbles laying around your house somewhere, and fits right in. So this acts as a front wheel. I'm done soldering. Turn that off. Excuse me while I clean up a little bit. Alright, so we mount the bearing caster to the front so that our robot will move around. Okay, these. I have 2 different size screws, so make sure I get the right ones. These are number 4 3/8 wood screws. Got from Ace Hardware for like 10 cents or something ridiculous. Pretty cheap. So put that in. Get started. Okay. And like I said, these the frame I had 3D printed from Pinocchio.com. The cutting plans, there are some Pinocchio, they have to be in a certain format for Pinocchio. The lines you want to cut all the way through are solid blue. Anything you want to etch in, so this has a little arrow here and arrow here showing you which way is up, are green. Red lines will be etched, and then you fill it with black, and you etch designs in. Nifty. I want to say before shipping, because the sizes they have a small size, but this is too many parts to print from the small size. So you have to buy the one size bigger. So the material is $6, and then cutting is $2 a minute. And because this one has a lot of cuts, where's that one? That's all these fine cuts, and then all the cuts in the wheel. I want to say it took 10 minutes, so it was like $24 for the frame to be cut, and then plus shipping. So it wasn't too bad. If you know someone locally who has a laser cutter, or a makerspace has one, I don't think we have one in Nashville, but you can get those cheaper. So now the balling caster is mounted, we'll mount the wheels. Let's just take the screws that were holding the axles in, put those back in. Okay. Hey William, can you do me a favor? Can you pull that off for me? Those 2 screws. So the other Arduinos I have, the extra, would work fine. Only I don't have a long USB cable for those. All I have is this little short one, which doesn't do very good when you want to drive a robot around. So I have a really long one that's USB mini, which is what that takes. All right, and we'll see how horrible my soldering job is. Okay, I think this is going to be right. Oh, I forgot I was supposed to solder this. Of course, I'm not going to solder it. Oh yeah, is it tight? Let's see if I can just spin these. Okay. So, got that. So we now have 2 wheels attached, ball bearing caster, 2 servos. All we're missing is the brain to go on top. And we have lots of extra wire. I will cut all this off.
Take the leads out.
Huh? Yeah, take all the leads out. All right, so now we have a breadboard. It's already got nylon washers from the last one it was mounted on. So line the holes up and remount it over here. I was going to use this board, which I loaded the formatter on and was controlling the LED with, but without a long USB cable, doesn't do us much good. This board already has the thinner formatter, so we're good there. Tighten that up. Good. Okay. So this is a SparkFun red board. It's just a Uno clone from SparkFun. I got it with my SparkFun Inventors kit. So it's got, instead of writing C code to do all this, we load the standard Fermata firmware, which I did earlier, and that's what Johnny 5 talks to actually control it from Node. So the ground wire, we have lots of pins here.
This SparkFun, does it also have an 18 mega?
Yes. Yeah, it's a Uno clone. It's, in all intents and purposes, exact same as an Uno. It just, the only reason I'm using it is it has a USB mini instead of a AB, and I have a really long mini cable. So we'll shove.
What do you need the cable for?
So when we go to control this, in a second, we're going to have to plug it up to the computer to run it from Node so that the Node app can talk to it. So if you have... What's that?
That needs to happen constantly.
Yeah. Yeah, as much as you want to do it. There's a... Yes. So there's radio controllers. There's also some other different boards. The SparkFun board, which I have one on order. That's not going to work. I'm going to have to solder these. Right. So the SparkFun board, or SparkCore, not SparkFun, SparkCore board, has a Wi-Fi module built onto it. It's got a Johnny 5. It's supported by there, and you can just program it to, I think you plug into it with a USB mini and have it connect to the Wi-Fi, and you can control it over the Wi-Fi. That's actually what I'll be doing next when mine comes in. All right. So these are not going into the pins like they are, so we just got to throw a little bit of solder on them so that we can. Yeah, somebody's blowing it. Where is? So. Far away from now. Let's up here. So just throw a little bit of solder on there to have something to stick into the pins. And the other one. Hold on. I might tip off a little bit. All right. So when we go to program this, you know which one's which. So the left wheel is here. I'll stick that in 9. Here we go.
I have to say, with the knife and the tattoos and the view and the electronics, you look like you're making a bomb.
Yeah. I think we get flagged on YouTube for that. So I put too much solder on it, and it's not wanting to go on the pin. Flatten this out a little bit. That's not going to work. All right, in that case, I'll shorten it. All right, try this again. A little bit more. So, okay. Again, the flux. Come on. Right there. Hopefully, not too much. Even it out a little bit.
Does hitting these leads like this make it a better connection, or do you have to?
Yeah, it makes it a better connection, and it also gives you a solid solid piece of wire to stick into the board. And I did not have nearly as much trouble with this.
It's one of those metal jumper wires that it can solder the wire of the pin.
Yeah. There we go. Okay, one down. Let's see if I did a better job with this one. So that one goes in the 9. This one will go in the 10. Goes in first time. All right, there we go. So should be ready to go. Oh. Other than, yeah, I don't have to do the same thing with this. I forgot. Make sure I'm getting the right pin. Ah. Sorry, guys. Okay. Get that down in there. Okay, that should be good. All right, so it doesn't look too good. Lots of extra wires, but I can fix that later. Theoretically, things goes well. That should work. All right. So back to this. So again, long USB cable. Plug this in. And away.
Take the knife to it.
Yeah. All right. All right. So this is the default code. I was going to write some of this, but now things go. That's not going to happen. So, all right. So we'll walk through it instead. Again, var 5 required Johnny 5 gives us the Johnny 5 module to actually talk to the Arduino board. Key press allows us to tie into the computer's key presses so we can actually control the robot. So we'll move the board, tie into the ready event, callback, write some console messages to tell us what we're doing. Then these are definitions for the servos. So we have two servos, one on pin 9, one on pin 10. They're both continuous rotation, so you can just send a command and it'll just spin. Just keep spinning until you tell it stop. You can tell it to go clockwise or counterclockwise. Servos, you can also tell them to go to a certain angle. These are the regular servos usually have a range that goes 0 to 180. Continuous servos have the gears done a little bit differently in different resistors, so that they'll just spin continuously, which makes them good for rolling robots. So we tie into the process to get the key press events, and then we press Q, we'll quit the program. If we press up, we will turn the left wheel, left wheel counterclockwise, the right wheel clockwise. So it'll go forward, and then for backward, we do the opposite, and go backward. For left, the left wheel goes counterclockwise, and the right wheel also goes counterclockwise, and it spins in place. And for right, we do both clockwise, and it spins the other way. And hopefully I pinned it correctly. Space sends a stop command to both servos. So let's see why I'm putting that. All right. And that's the extent of the code to control it. So, node Sumobot. We install the key press module first. Key press. So, when you first turn it on, you have to zero the servos out because they don't know where 0 is. So they're both turning in different directions. We sent stop commands, so they think they're at 0 and they're not. So they have little screws. That doesn't help me at all. So there's little screws in the back of that, and you just turn those until the wheels stop moving. It's adjusting the home spot on the servo. So it's adjusting where 0 is, where 0 degrees is. Yeah. Just till the wheel stops moving. And my right wheel's not. I don't have a good connection on the right wheel. No, that's the other one. So, did I get it, or is the power? So that should be good. So now, theoretically, I didn't mess anything up. Oh yeah. I do in here. And yeah. My right servo is not giving me a good connection. It's this one. So anyway. Let's see. Probably doesn't have enough solder on the end to get a good connection into the pin. Let's try. Q. There we go. Left, right. Yeah, let me pull this down here. There we go. So, come down here. Forward, backwards, left, right, and stop. So, now that fun process is over. We coded it. All right. So, if you want to build your own one of these, depending on parts you get and things like that, you're looking at spending somewhere between 50 and 70 bucks. That link will send you to a GitHub repo with all these slides. I gotta edit the README, but I'll put links to the designs for this and all the Johnny 5 code. I had all the frames cut from Pinocchio. I've had really good luck with those guys. I actually have had some other stuff laser cut for them recently after using them for this. They do 3D printing as well, but I found that Shapeways is substantially cheaper than Pinocchio. I think Pinocchio might be good if you are doing bigger stuff, but I think they have like a $10 minimum. So whereas Shapeways, the bearing casters cost me like $5, and these little wheel hubs, which I wouldn't use again, were like $2. Where I think Pinocchio wanted $10 for each one of them. The servos I got from Polo Loop, as well as the battery box. The servos were $13.55 a piece. The battery box is a little bit over $1. If you go on eBay, you can find continuous rotation servos that are the same size, like Chinese knockoff, for a little bit cheaper. So if you're that worried about $4, I think you can get them for about $9, $10 on there. We're buying like 40 of them for something else. We may look at that, or I may look at that. But if you just order them, I've had really good luck with these. They're really good. I got these Unos off Amazon for $15, I think. If you're willing to wait, you can get other Uno clones off eBay for $10, $11, or just buy a real one. All the other miscellaneous parts, I got marbles from, I think, Ace Hardware when I was checking out buying the screws because I needed extra. My kid lost dumped his things. I couldn't scavenge more. I needed 3. So I've got one there, one here to build that bot. All right. So JavaScript and hardware. Like I said, this is a Nodebot. We were controlling it with the Johnny 5 module from Node.js. Cylon.js is another Nodebot framework. I've looked at it. It's a lot more verbose. I think Johnny 5 gives you a lot of the power that Cylon would too. It's just Cylon makes you up front. If you know a lot more about hardware and things like that, then you may like that. It has a couple different things. They're kind of going different ways. Worth checking out. Tesla board is another board that you can write firmware for a microcontroller in JavaScript, and the same thing with the Espruino. Any questions? Yes.
The files that you use to send to those companies to have fabricated.
Yes. Yes. In the Sumobot Junior GitHub, there's a cutting plans folder. There are .eps files. So he has the basic ones that he did originally. He cut everything at a makerspace in Las Vegas. Pinocchio requires a special format. There are Pinocchio-specific files up there. There's a 3mm and a 5mm for this design, which is the older design. I actually uploaded and took the pull request to do 2 of these. So the different material sizes, they have a P1 and a P2 size. One of these will not fit on a P1, it's too small. But then with a P2, you have tons of extra space. So the materials is $6, and it's $2 a minute for laser cutting. Ended up being $30-something to print 2 of these. So I printed 2 on one board. And that is in the GitHub repo under cutting plans. That code file I ran, the Sumobot Junior code file, is the example code that's also in there. It also, under 3D parts, it has the STL file for this bearing caster. So you'll need this for the front wheel. And the files are .eps files, which is a vector. I forget what it stands for, but it's Adobe Illustrator, Inkscape, things like that. You can edit them. The Pinocchio files, they're looking for a specific format. It's a little bit bigger. Has a white space in the middle. That's your cutting area for that size material. You'll do solid blue if you want to cut all the way through, and it has to be 0.01 millimeters thickness. Again, all these are already planned out, so you wouldn't have to touch anything. The only modification I made was I actually added the etching for the logos, which didn't take too much time. I did a trial of Illustrator from Adobe Creative Cloud. Anyone else?
I understand you said for your servos, why not go with, say, a step motor so you can have more capability?
Like I said, the design came from him. I think it's just ease of use with a continuous rotation servo. It's just one pin in. You don't have any diodes, anything like that. You don't have to worry about motors and things like that. So it's a little bit more expensive, but it's also easier to hook up. A little bit simpler design. If you were getting serious about it, then yeah, you'd probably do DC motors, stepper motors, stuff like that.
Have you experimented with any AI, or maybe having 2 of these guys chase each other with a camera? Or
not yet. Like I said, I'm going to be ordering a Spark Core and a Raspberry Pi. I want to make one of these wireless. Is my next task on my plate. And then some caveats with Johnny 5. I will say, if you have hardware lying around, go ahead and try to use it. It has a lot of classes. So I was using the Servo class and the LED class. They have sonar classes for rangefinders. They have motion detector classes. They have gyro classes. Some of the stuff I'm running into, though, is because there's only a couple guys maintaining this, if you don't have the model sensor that he wrote, the likelihood of it working is hit and miss, depending on what it is. The gyro I have, the ranges that it's sending off are different than the gyros he programmed with. He did a 2-axis gyro. I have a 3-axis gyro, and I'm not getting good readings off of it. It works fine when I do it in C under Arduino, under just a straight firmware. I'm probably going to look into getting that working with a Johnny 5 class and submit a PR for that. Rick Waldron, who maintains Johnny 5, is really active on Twitter. He sent me stickers that are back there for free to give out to anybody who wants them. He's responded to me about a couple issues I had with a ultrasonic sensor. Took a pull request. I fixed the breadboard in the docs for it. Same thing with Powell, whatever his last name, Makenai, who designed the Sumobot. He's been pretty active. He takes pull requests for the Sumobot designs. This is a newer design. NodeBots Day is the 27th of this month. I think that's what this design is for. The day before I ordered these off of Pinocchio, he had updated, put these new designs in a subfolder, and they looked really cool. So I grabbed the new ones and printed an old one, and I like the new ones, but it is a little bit different. All the instructions and everything you need is currently in the GitHub repo is for this old one. So you zip ties the servos in, and the screw sizes are number 4 by 3/8. Like this one takes number 6 by 3/8 for the servo mounts, and it's a little bit smaller. The battery box goes in this way instead of this way. So for this one, the battery box goes in that way, and it's a little bit looser. again, he has a video up on YouTube of him demoing all this. I would glue these together and just held them with a wood clamp overnight. I wasn't going to do that here, because that wouldn't work. Anybody else? Going once?
I'm curious to know about the interface.
Mm-hmm.
That's all over serial port, right?
Yes. So the Johnny 5 module uses the USB serial port, and then it talks to the standard Fermata firmware that's on the Arduino, and it just sends commands back and forth.
Is it actually encoding commands, or is it just looking at levels?
I'm pretty sure it's actually encoding commands back and forth to the different pins. I've looked at that code a little bit, and it's very C-like.
Oh, yeah. Does the key store anything? Is it memory that you can map it out?
That would be more low-level Arduino stuff. You can do that with the Arduino all day long. With the Johnny 5, because it's being controlled from Node, you would actually have to hit the serial port. And with the Spark core, you can have the standard format on that, run Node on the laptop and control it over Wi-Fi. Which that's my next project. Spark cores are $40, and for $20 you can actually get a little shield that it'll plug into, and it'll fit the Arduino Uno footprint and take Arduino shields. So, also, like I said, if you have access to a 3D printer or have a 3D printer, he has done a full build out on one of these bodies 3D printed. So instead of laser cutting wood, you can 3D print the whole thing, which is going to take a lot more plastic and a lot more time and not be as cost effective, but a lot more people have 3D printers nowadays than laser cutters.
With the BeagleBone module on there,
Mm-hmm.
is that for controlling itself from Node on BeagleBone?
I believe so. So I haven't messed with that one yet. Like I said, I have a Raspberry Pi in order, so I'm going to play with that. It's they're separate repos. So if you go to the Johnny 5 GitHub repo, he has links to the people that maintain all the different modules. So there's a Raspberry Pi module, there's a BeagleBone module, and all that. I don't see why it wouldn't be that way. But I don't have a BeagleBone yet, so I haven't got to play with it.
More in-house than the Raspberry.
Yeah. Yeah, yeah, we actually have them at work. They're giving them out for Engineer of the Month awards. I haven't won Engineer of the Month yet. So. Yes? So, thank you.
Thanks, everybody.
Again, so I'm Rodney Norris. I work at Forcex down in Brentwood. We make military software. There's my email. There's my Twitter. So, have any questions, hit me up. I'm available. I'll tweet out a link to the GitHub repo with the slides and all that good stuff. Yeah.
I got a couple announcements for you guys. I want to stick around for just a few minutes. And please take home any extra pizza or beer. Don't drink in your car. Or don't get caught drinking in your car. We get my screen situated here. Hide on my wife's text messages.
Oh.
Okay. Okay, cool. All right, sweet. So first things first, next month, Jason is going to be doing a really cool experiment with us all. It's a hands-on software development, software engineering. Yeah, you want to say a couple words about it?
Well, I don't know. I don't know how much to spoil since I didn't prepare everyone, so I'm not saying too much. But like next month, second Wednesday next month, we're gonna all build something together in like 3 hours. It's gonna start a little early.
We're gonna start a little bit early.
So like
Say 5:30.
We'll
Maybe run a little bit later.
Yeah, but try and show up as soon as you can because it's gonna start. It's gonna be really fast, and if you know anybody that's like really awesome with Illustrator, or just generally graphics, sounds, I want to like drag them, visit them. That'd be fun. That's it. Anyway,
we're being purposely vague, but it's going to be awesome. If you get to his prisoner dilemma, what's that?
It's gonna be something.
It's going to be great. It's going to. I have full confidence in you. If you went to his prisoner dilemma talk a couple months ago, like you know how much fun that was. It was great. So this is going to be a lot of fun. So please come out next month. If you're interested in speaking at NashJS, hit me up on my email. Tell me what your talk's going to be about, and we'll try to get you on the schedule. Try to get a little bit more diverse talks going on. So as you can see, we're trying to branch out from this is the node package, and this is how you run it. So also, if you're interested in sponsoring, hit me up on email or Twitter as well. We can fit you in. We always take sponsorships. A special thanks again to Fernando and Scott in person for giving the beer and the pizza for tonight. Let's see. All of our contact information is here, Twitter. If you're an IRC user, please come and join our channel. Pretty active in there if you need help or whatever. Just want to go grab some hot chicken for lunch. We'll say, hey, we're going to go hit these. So website doesn't have much on it, so you can just kind of, oh, sorry. You can kind of ignore that one. I don't know what happened. I'm sorry. I don't know how to computer. Oops. Okay. Let's go here. There's Fernando, and there's the little person logo. Oh, okay, so this is the important stuff. Call for proposals has started for November, so if you're interested, does everybody know what November is here? Have you guys all heard about it? Been blasting the crap out of it on Twitter. If you don't know what it is, it's a JavaScript and Node conference that we are organizing here in Nashville. It's going to be on November 15th and 16th. It's going to be a 2-day conference, roughly $100 or so for the tickets. You can get tickets now on sale for the early bird price of $75. It's going to be great. We're going to have tutorials, we're going to have speakers, we're going to have giveaways. It's going to be sweet. And on top of that, Coder Fair, which is another great conference here in Nashville, which is more of a general developer conference. Their call for paper closes on the 20th of this month. So if you're interested in speaking, please get your papers in and submit those as soon as you can. Selection process is pretty grueling, so we want to get you in there as soon as you can. And I think that's it. There's a nice zombie here. So thank you for coming. Please take the beer and pizza with you. I don't want to have to throw it away, so thanks. Thanks again for Rodney. He did a great job. And also thank you to him for, he printed out some nice new NashJS stickers. So please take those too.
Yeah. There's also Johnny 5 stickers up front. If you want one of those, feel free to take it. My business cards are on there if you're so interested. Thank you.